All right, guys, so let's look at this problem right here and get a clarification on everything. So first of all, we have kind of want to zoom in out, zoom out a little bit. And what we want to focus here on is this circuit here. Now, previous circuit looked like, obviously, like this, right? So this is example one, previous circuit one, and two. Here it looks like, wow, what is all this? This looks really, really crazy, right? Actually, it's not. It's very simple if you follow the steps, okay? Again, you would have to have your cheat sheet out. So I would create, again, go to your cheat sheet, create a cheat sheet with, just like here, a series circuit with 2 resistors, just like so, and then a parallel circuit with 1-to-1 here, just like so, okay? And here you would have your equations, okay? So let's get started, okay? So let's do a comparison real quick, okay? So when we get started with this, here we see and you're going to work from this way in, okay? Not the other way, this way, okay? Now, if you're more advanced and, you find this stuff pretty easy, then yes, you may get creative and start, maybe skipping steps. But until you get good at this, really, I would not advise anybody to skip steps. Okay, the circuits can get very, very complicated, and skipping steps is not the best advice, the best course of action. So let's look here. Okay, first thing we use the nodes, right? So we have these little dots called nodes. These are called intersections. So I go from A to B. We can call this, A. We can call this B. It really doesn't matter. Okay. Now, if you look here, what does this resemble? Does it resemble this or resembles this? Oh my gosh. It resembles both. So look, we go from A to B, and we have a branch here, and we have another branch here, and we have another branch here. So I go from A to B, wow. And I go from A to B, what does that look like? Does it look like this, or does it look like this? It looks like a combination of both. What do? Understand this phenomenon, okay? This has to be 1-to-1. If this is not 1-to-1, it's not parallel. So your option is to go to series. Okay? Series are things in a row. So now if you look at it, it's in a row to make it. So you have to make this path here 1-to-1 to go to parallel. Okay? How do we do that? Well, let's get started. Okay? If you want to look at this real quick, first thing I want to do is make R equivalents. REQ1. REQ1 is here, we have it in series, but we have more than 2. Well, it doesn't matter. You just add them. So you just say R3 plus R4 plus R5, just like that. Okay? Just like here, except you have more than, here you have 3, you have 2, but the equation still applies. Okay, move the mouse out the way. So here equal to, R3 is R1, which is 5. R4, which is R2, which is 10. R5, which is R3, which is R1, which is 5. Right? By the way, I got a new projector, guys. So, a document projector. So obviously this is a lot more space. I can operate a little easier these days. Just want to give you a heads up on that as well. So now we have REQ1 equal that. What do we do? Well, this REQ here is equal to REQ1. Just like so. Now, how do we handle that? Okay, so what we got to do now is reduce that. It's gotten reduced to 1 resistor. So we have to make some space here. Obviously, you want to go 2 to 3 circuits a page. Okay, do not try to cram this in. If you try to save paper on this, it's going to cause a lot of problems. Okay, now if you're short on paper, best thing to do, you can use the back of anything, right? Back of paper works just as well. You want to redraw this entire circuit, just like so. Okay. Okay. Now, Okay, so here you have plus Vs. You redraw the circuit to from here. You copy R1, just like so. You copy R2, just like so. And here you have all these three into one resistor we call REQ1. REQ1. Now, what do we do with REQ1? Well, how do we handle this? Well, what does it now look like? Does it look like this? Or does it look like this? So when you have that A and B nodes here, so you will redraw the A and B nodes just like this as you go from here to here. The only thing that changes is here, right? You're operating one pathway at a time, okay? So here, it's obviously, it branches 1 to 1. This relationship is 1 to 1. This relationship is 1 to 1. So it has to be this equation. So we're going to call this REQ2, right? And I wrote it a little below. I could actually, probably write a little higher. Give me an eraser. Let's just erase. Get good at erasing. REQ2. Now I can take that and I can just put it right here, right? Showing my calculations. REQ2 is basically R2 times what? These two here, REQ1 over R2 plus REQ1, just like that, okay? You have to be able to make up and understand how to make up variables as placeholders, right? Nothing's going to be given to you, okay? Part of the challenge is how do I, create placeholders when there are no placeholders, right? That's part of the lesson of this class, right? So from here, what do I do? Okay, well, here is that. That's going to go down to 1 resistor. How do I bring this down to 1 resistor? Okay, again, I got to redraw the circuit as such. Just like that, I redraw. Okay, so here we have R1, and this is really not supposed to be like little loopy. It needs to be very jaggedy, right? So you just want to make sure you get this right all on. This is REQ2. Okay, so REQ2 is this value here. Okay, so R1, let's figure out what the values are. So what does this look like here? This looks like, what does it look like? Does it look like it's branching out? If I have A and B here. By the way, I'm going to redraw this circuit. Maybe it's just because I'm, a little OCD, but it's just got to be clean. Okay, REQ2. So now, does this look like this going from A to B? Does it look like this here? No, it's not branching. It looks like that. So your equation will look like this. REQ right here. I'm just going to write it side by side, or I'll put it below so you can see it, right? REQ3 is R1 plus REQ2, just like here. R1 plus REQ2. Okay, if I were to, I didn't even put in the values for the previous one. Look at that, I forgot. Shame on me, right? So let's do this. Let me go ahead and put the values in for REQ2. So REQ2 would be 10. I'm sorry, R2 is 10, REQ2 is 20. So this is 10, 20, REQ1, over 10 plus 20, which gives us what? That would give us 10 is 200 divided by 30 is 6.67. 6.67 ohms. 6.67 is really here. So what we do now is say, okay, look, REQ3 is R1, which is, sorry, let me go back here real quick. R1, which is 5, plus REQ2, which is 6.67. So 5 plus 6.67. This stuff is not hard if you keep track of everything you do. Okay? 5 plus 6.67 is 11.67 ohms. Okay? What do we do from here? We redraw the circuit again. Okay? So from this will be our final drawing. Okay? So we will go ahead and do this. I'm going to draw it from here. Okay? We're going to get this down to one resistor. So here become REQ3. Okay? So what do I do? And by the way, this is plus VS. I redraw the circuit again. Okay. VS. Just like that. Okay. Just like that. And that is equal to, and I'm going to move this up a little bit for you guys. Okay. So that is equal to 11.67. What is our VS? Our original VS value was 5. So I go 5. This becomes 5. As such here. Okay. Now, what is? I would just have to say that's our 5 volts there, right? What is I? So we have to draw an I, right? So every of these components will have a V equals IR. Okay, that's the equation you just got to know. Okay, and so where is I? Well, I is here. We're going to call this I1. Okay, and then there's an I here. Just like that. And we call this I1. It doesn't really matter. Okay. So if I were to say V equals IR, so I would be equal to V over R, which is VS over REQ3. Okay. That would give us what? 5 over 11.67 ohms. I is equal to, I'll use my calculator. Okay. You can see it, great. 5 divided by 11.67 is 4.29, 0.429 amps. Okay, and that's your answer. Okay, so this is how you would handle this problem. Okay, if you have any questions, please feel to review the video. If you look at it side by side, your answers look like this. Right, so the whole entire step process, and if I'm going to try to get it on one screen, I can. It's really hard to get it on one screen, but the process would look like this. You would have one page here, okay, and then you would have a second page here, okay. So feel free to pause the video at certain points, look at the calculations, and go from here.